We want to find the derivative dy dx by implicit differentiation. So we're treating y as an equation in terms of x. So anytime we take a derivative of y, all of our derivative rules will apply. And so we are not going to solve for y before we do the derivative. We're just going to take the derivative. So the derivative of x cubed is 3x squared. Next, we've got a product here, an x squared times a y. So we've got to do the product rule. The derivative of the first times the second plus the derivative of the second. Derivative of y is dy dx times the first. Plus, now we've got derivative of 4y squared. What I like to do is I like to put some parentheses here to remind myself that this is a chain rule problem. So something raised to the second power, derivative of that is 2 times something to the first power. The inside function stays inside, and then we take the derivative of the inside. The derivative of y is dy dx. Notice here, the reason I'm using dy dx's everywhere instead of y primes is because sometimes y to the firsts and y primes look the same. So note, this is y to the first power right here, and this is the derivative of y with respect to x. Next, we're going to move to the other side of the equal sign. The derivative of 6 is 0. At this point, we want to get anything with a dy dx on one side and everything else on the other side. So I'm going to leave the x squared dy dx and the 8y dy dx on the left-hand side and bring everything else to the right-hand side. So we have minus 3x squared minus 2xy. Now I'm going to factor out a dy dx from the left-hand side, giving me x squared plus 8y times dy dx is equal to this stuff over here. And then last step will be divide both sides by stuff in front of the dy dx. And I have solved for dy dx.